I have. Hello, how are you?
How are you?
Good, good. What's your full name? What I'm seeing thrown here.
My full name Tavon Rome.
Yeah, wrong. Okay,
I'm your favorite student. Hold on, I'm ready to change it right now.
please. Yeah. Yeah.
I'm the first one here, so I should get an extra 10 points.
I'm sorry. I'm sorry, Tyrone. It doesn't work that way. But you get your point when you do some work. You hear?
Oh man.
All right, how you are doing?
Doing well. What's up? How you doing?
Fine.
I got a question for this homework that we just had. I didn't
Yeah,
like
that was
nothing about
hard.
them last questions.
Which of them?
No, because it felt like them. It was like 3 questions on there that I don't think we ain't never go over. Cause I was like, and then on some of them like you know like the little the chart we supposed to go off of to find
Statistical table.
yeah, like it wasn't the same. It wasn't like this. I had to use the table that was on the my lab thing. I had to use that table. It wasn't the same table.
Yeah, remember I said in the class that you have. I recommend you use the one you use in class because that's the one I showed you how to use.
Yeah,
That
no,
table.
but what I'm saying is the one that you showed us in class wasn't giving me the answer that I needed for the one that was for the homework.
But if you use it properly, it will give you the answer. Now, which one do you use for the homework?
I used the one that we were supposed to use. But the crazy, like I said, I used the one that was on my lab, like on like the chart that was on there, because the chart that we went over in class,
The
it
one
was
we
not
had,
the same.
it wasn't working. That one
It
working
was
for us at all.
If
it
you use
wasn't
it,
the same.
if you use it the way I showed it, it will work. But if you're more comfortable using the other one,
No, I don't think you hear me. No, what I'm saying is not that I'm not comfortable. It's the fact that it was not the same. Like, okay, say if you had 1.4, right? 1.47, and you go down on the left hand side, you go to get the 1.4, and then you find at the top the 7. Go to the 7 column. On the homework, it say like 0.9999. I'm just using an example. 0.9999. And then on the chart that you gave us, it say like 8 point something, 8 point da, 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 I'm just using an example. But the one that's on the chart that you gave us don't give me the correct answer for the homework. Like the chart that's on the homework, is giving me the correct answer.
then if you can use that one, then use that one. But maybe if you look at the correct, they are basically the same type of. Except that mine is the one I show in the class is not cumulative. So you have to follow exactly. Look at the procedure table before you can now follow the direction from there. But the one on the homework is cumulative. Is different. So if that one is giving you the correct answer, that means you know how to use that one better. So use that if that's what that one is giving you correct answer. Now the chart I gave you is if you use it, follow all the guidelines there, you still get the correct answer. Both of them work if you know how to use them.
But it's only 4 people in class today. What's going on?
Don't worry about them. Just since you're here, that's the most important thing. I send the announcement and both here and in Canvas. So it is now up to them to be here. So now the homework questions. What I can do is to maybe give you another chance, but all the questions there will solve similar example in the classroom. So I can, if you want, I can put it back, give you another 1 week to redo it. Other than that, there's really nothing I can do about it because I covered everything that we supposed to cover in that homework. I picked the question myself. So
I should have said.
I picked the
You
question
said
myself. So
you said you did them.
Huh?
You said you did all the questions.
No, I picked them myself. So I made sure that I picked only the topics we covered. So if you want, I can put the homework back again and give you another 1 week to complete it.
I wish I took a picture because I want you to see what I'm saying. Like, I think it was like the last 3 questions I just did not do because it was like I didn't know like I didn't even know nothing. Like I tried everything. Like I did everything that I could and it was not getting no answer like at all. Nowhere close. So
when you start take it the second time, when I put it back, then you can take the picture and bring it. Let me see. All right, let us begin now.
Hey, I'm coming in kind of late. I missed what y'all was talking about.
Yeah, I told him if you when I put it back again, I'm gonna put it back again for you guys, so that when you're doing it again, you can those 3 questions you can take a picture of it. Let me see them.
Oh, what back? The homework?
He was saying that there's the last 3 questions that we didn't do it in class. So I told him that the questions I put in the homework, I picked the questions myself. So I made sure I picked the questions we did in class. So now, if I put the homework back again for you, that's the last homework, right?
yeah.
Yeah. When I put it back again for you, then you can do it, and then those 3 questions that you mentioned, take a picture of them and then show me. Let me see in the class. I'll be in the class next week. So
everybody get to do it over?
Yeah, I'll put it back to everybody. Yeah.
Oh, okay.
Now, this Zoom doesn't only give 40 minutes. So when we finish this first 40 minutes, we're gonna close, then log back again to finish the remaining 40 minutes. Because you only give 40 minutes. So that's how we'll be doing it. 40 minutes, we stop, then I'll put it back again, then another 40 minutes until we get to where we're supposed to be tonight. Okay. So tonight, what we will be doing tonight is confidence interval. After this topic, confidence interval, I'll upload your project so that you can begin on time to work on those. So confidence interval simply means interval that it gives us an estimated range of values that an unknown population parameter can have. Now, when we say population parameter, I hope you can see my screen. When you say population parameter, we are referring to things like the mean, which we can represent with a symbol of mu. See? Then make this thing bigger so you can see it better. So, and then standard deviation. These are what we call population parameters. The numerical estimate of the population characteristics. See, or even proportion can also be a population parameter. Yeah. So a confidence interval give us an estimated range of value that these population parameters can have or can be. So when we do confidence interval, we're trying to estimate the value of the population parameters. Now we have 2 estimates that we do. We have the point estimate. In this case, we are referring to the single numerical value estimate of the parameter. For example, we have a local bus driver can say that the average gas price in 2018 is $2.34. See, one number. That's why we call it a point estimate. Ford CEO can say that on average, 200,000 cars were made in 2013. Again, one number, only one number, 200,000. The other one, only one number. So we call it point estimate. Point estimate. So now, for population mean, the best point estimate of the population mean is the sample mean. Okay. Now, but what we are interested in is the interval estimate. And the interval estimate this simply means it gives us the range of values that we use to estimate the population parameter. In this case, we have two numbers, the lower side and the upper side. For example, a local bus driver can say that on average, the average gas price in 2018 is between $2 and $3. So you can see that we have two numbers here. That gives us a range. And that is the one we're interested in tonight. So it gives us a range of values. Ford CEO can say that the company produced on average between an average of 190,000 to 250,000 cars in 2013. You can see the difference. I have two numbers, unlike the point estimate, where we have only one number. So this one that gives us the range of values are the one that we're interested in tonight. Now, to estimate it, we need to have our confidence level. The confidence level tells us the likelihood that the range of value we have, or that the true population of the mean or any parameter lies within the range of values that we have. For example, we can say that we are 90% confident that the sample mean or the population mean lie within the range. For example, this bus driver can say that he is 95% confident that the average gas price in 2018 is between $2 and $3. So now, if you say these are the three key confidence level we use in statistics. The other ones, you can use 85% confidence, you can use 98% confidence, but these are the common ones that you will see in the most questions in your class. If you say that you're 90% confident, it means that your chance of being wrong is 10%. If you say that you're 95% confident, then your chance of being wrong is 5%. And when you say that they are 99% confidence, their chance of being wrong is 1%. So now, before we can use this, we need to get a critical value for confidence interval. Now, there are other ways you can get it, but there's a shortcut method you can use. That method is this: they use Z alpha over 2. Why alpha over 2? Because you have two sides, the lower side and the upper side. So P over 200, where P represents the confidence level. 200, of course, you know that percent is 100. So you have 200 on left side and on the right side. So that's why you use this 200, P over 200. So this will give you a quick method of finding the critical value for a confidence level. So I have some of those critical values here, but I'm going to show you how they are calculated. Okay, this critical value should simply mean just the number in the borderline that separates the sample statistics that are likely to occur and from those that are not likely to occur. So I have them here for different confidence level. So for 90% confidence level, if you say you're 90% confident, your chance of being wrong is 10%, which is the alpha. And in that case, the critical value will become 1.65 or 1.645. If you say you're 95% confidence, then your chance of being wrong is 5%, which gives you alpha as 0.05. And the critical value will be 1.96, and so on and so forth. So let me show you how to get these numbers. Again, remember I said that the formula is this. The other ways you can do this, but you can just use this quick method. Now, the first example, it says here to find the critical value, find the critical Z alpha over 2 for a 95% confidence level. So a solution for this solution will be you have Z alpha over 2. That's define a critical value. So write it down here. Equals. Okay, let me see. Equals, remember it says P over 200. So you gotta be P E over 200. That means it's a 95, it's a 95%. So P over 200 will be 95 divided by 200. So now from our calculator, you can see that 95 by 295 divided by 200 is 0.475. So it's gonna be 0.475, 0.4750. Now you can now look for this on the table of normal distribution that I showed you, the statistical table. So we find it where it is located here and look for 0.475. You gotta make sure you're looking at the right table. So 0.475, look for it here inside. 475, you can see right here. And then you follow it to the left. You get 1.9 and follow it up 6. So 1.96. So I'll just give you the critical value as 1.96. And you can see from here, for 95%, you can see 1.96. Any question on that? Any question?
No.
No.
Now, like I said in the class, please be sure I recommend using this table. Some of you got the homework, score very high on that homework. That means that some of you really know how to use the table. Anyway, so I can show you another example. Let's say that it is, this one is still 99% confidence. Find the critical value, 99% confidence. Again, the formula is Z alpha over 2 P over 200. So I'm gonna copy it from here. So I can see this gives us a solution. Okay. All right, P over 200. And in this case, our P is 99. So you gotta do 99 over 200. Then we go to our calculator to get our answer for that, 99 over 200. So 99 by 200. I'm going to try and upload some of these videos. So this gives us 0.495. So I'm gonna write it down. 0.495. Now in that table, everything is 4 digits. So I'm gonna make it 0.4950. You got 0.4950. So you can see right here, 0.4950. Now look for this on the table. Again, make sure you're looking at the right table, table 5. See, table 5, which is standard normal distribution table. So 495. I got 4901. So you get 4948. I see, I saw two numbers, 4951 and 4949. So this one is, both of them are equally close, because if you have 4951, let's see, write them down, 4951 and 4949. I write them as if there's no decimal point. If you go to the calculator, I didn't see exactly 4950, so but these are the two numbers that are close. So let's see which of them are more closer to it. I think they are both equally close. Let's see. I got 4951, 4951 minus number we have, which is 4950. Give me 1. And we'll do the same thing with the other number. If I got 4950 minus 4949. I get 1. So they are equally close. And like I told you in the class, whenever they are close, equally close like that, all you have to do is use the one that is bigger. So I got 4951 is bigger. I follow it to the left. I got 2.5. And then up 8. So 2.58. I can see it right there. So go to there and put their critical value as 2.58. Okay, 2.58. So now that's how to get it. Once you can figure out how to get the critical value, then getting the confidence interval will not be easy for you. Now I'm going to show you on the table, the statistical table where they have a list of them, the critical values. You can see it is on this table right here. You can see the critical values. For 75%, critical value is 1.15, sorry, 1.15. For the one we just did, for 99%, you see 2.58 right there. The one we just did. For 95%, you see 1.96. So, any question before we proceed to the finding the confidence interval? Any question?
Just to clarify.
Yeah.
If there are two numbers that are equally close, you just use the bigger one?
Yeah.
Okay.
Now, let us do the confidence interval now. So now, in most cases, you have the critical value. Like I showed you on the table, so it's there. But if it's not there, then you have to find it out by yourself. But in their own case, it's there. Now, let's do the first case on the finding the confidence interval we do is confidence interval for the mean when the sample size is large. We say that the sample size is large if and only if it is more than 30. See, n is greater than 30, greater than or equal to 30. And also, if we know the value of this population standard deviation, in that case we use this. So to do that, all we need to do is to get our values, get our critical value, plug it in to get our confidence interval. And also remember that the best point estimates of the population mean is the sample mean. Look at our first example. The first example says a sample of reading scores of 35 fifth graders has a mean of 82. The standard deviation of the population is 15. Find the best point estimate for the mean. Find 95% confidence interval of the mean reading scores of all fifth graders. And find the 99% confidence interval of the mean reading scores of all fifth graders. So let's start. First one, it says, find the best point estimate for the mean. Now remember I told you here that the best point estimate of the population mean is the sample mean. So that means that answer, just give us the answer to the first question right there. So answer solution becomes, you see that the best point estimate of this population mean of the sample mean is the population mean is the sample mean. See, the best point estimate of the, I wrote it twice, that's why. The best point estimate of the population mean is sample mean. So you see that the population mean, the sample mean is here is 82. So our answer becomes, they find the best point estimate. Since we cannot get the character of sample mean here, I'm going to take you to this workbook so I can get it. Sample mean is 82. That is my other workbook. Okay, I opened so many. Okay, let me see. Okay, see. I think I opened so many pages. So I'm seeing. Okay, I'm gonna close some of them. Let me see what I need to close here so I can see.
We can't see what you're doing.
I opened too many pages. I want to get to my workbook. Okay, let me open it from here. So I can work on that. Okay, then I can share it. Okay, can you see it, the blank workbook? So the best point estimate for the population mean is the sample mean. So that means in this case, our sample mean, we see that a sample of reading scores of 35 fifth graders has a mean of 82. So our sample mean is 82. To have it here. So to get the character that we're looking for, you have to use this 82. So you got X bar equals 82. This is the character for sample mean. X bar equals 82. And that answered the first question right there. Okay. X bar equals 82. We go back and put it back in. So X bar is 82. So that's it. That answers our question. Any question for that? Any question on this?
Yeah. So the answer is 82.
Yeah, because remember I said here the best point estimate or the population mean is the sample mean. So here they give us that the sample of 35 fifth graders has a mean of 82. And they ask you find the best point estimate of the mean.
Oh, I'm tripping. You just answered the first one. Okay.
And part B is where we need to do a lot of work. That part B is where you do the confidence interval. It says find the 95% confidence interval of the mean reading scores of all fifth graders. So what you're going to do here is to first of all list your values. Okay. We have our values here. The first thing is a sample of reading scores of 35 fifth graders. That means our N is 35. Has a sample has a mean of 82. That means sample mean we just have 82. See? And the standard deviation of what again? Okay, see. Let me make it bigger so you can see it. And standard deviation is what? It says standard deviation is 15. We can get the character for standard deviation from here, which is 15. 15. I change to that. And always change, do that. So I will put it back again. Now, it says 95% confidence interval. For 95% confidence interval, the critical value, I say to you, that was the first example I did, is usually given. You can get it from here, or you can get it from the statistical table, which is here. I go all the way to this table at this back. This one here, you will see it right there. 95% is 1.96. So you can see it in both places. Okay. If it's not there, then you have to calculate it by yourself. So it's for 95% is 1.96. So you go here and put the critical value Z alpha over 2 equals 1.96. So again, if you don't see it, then you have to use the formula of P over 200 to solve it, to calculate it, okay? But we have it already, so you can just put it in. Now, we need to find the error margin. To get the error margin, we need a formula, and that formula is this. I'm going to write it. This page will not allow us to put it, so I'm going to take you to the other workbook. The error margin is find using this formula. Error, which is the E, equals Z alpha over 2 at z alpha over 2. Okay. Okay. See, Zoom give us, we have 10 minutes before we go on break. So z alpha over 2 alpha over 2 then times standard deviation over root n times the standard deviation is the symbol is right here. Okay, gonna be somewhere here, but the square root of n. Okay, n. Okay, so that is the formula for error. So that means we need to get all these values. We get the alpha over 2, we have our standard deviation, we have n. Let's go and get them and put them here to get our the error margin. Okay. So I got the z as the alpha over 2 as 1.96, and then we get the standard deviation as 15, and n is 35. We plug it in to get our error margin. Okay. So we go there and plug them in into the formula to get our error margin. Okay. 1.96. Okay. Times get standard deviation of 15 divided by square root of square root of 35, so that we can now go to our calculator to get this error margin calculator. So it's calculator right here. So you have clear this 1.96. Okay. 0.96 times standard deviation of 15 divided by square root of 35. Okay. 4.97. 4.97. So we can go and put it in 4.97. Okay. Then we copy it and paste it on the main workbook. 4.97. 4.97. So let's copy it. Go and put it on the main workbook. Then we can go from there to get our confidence interval. So we got 4.97 as the error margin. So now, once you've done this, you can get to 95% confidence interval. So the 95% confidence, okay, confidence interval is given by this formula is forgetting it is, I'm gonna pick it from that place again. S bar minus error. So I'm gonna get it from there. Our S bar is this S bar minus error. Okay, less than the mean, which is what we are trying to estimate. We are trying to estimate the mean. Then less than under X bar plus error. So you add the error on the left side and you subtract the error on the right side to get their confidence limits intervals. S bar minus error is less than the mean. It's less than S bar. So this is the formula to put it. So S bar minus error is less than the mean. It's less than S bar plus error. So this is the mean we are trying to estimate here. This mean. Oh, I didn't put the other S bar plus error. So excuse me. Sorry, I gotta put this right. S bar plus error. Sorry, excuse me. Plus error. I gotta put it right way. Okay. Now we have it here. Error. So let me move this down so we can have a better view of it. So, oops, enter, yeah. Together with the equation. So now, you can see the better view now. So now we have S bar is our sample mean. That means 82 minus error. Our error is 4.97. It's less than the mean. Okay. Okay. Mean less than S bar plus error. I mean, it's 82 plus error, which is 4.97. So you can see that. So in the left side, you subtract, on the right side, you add. So when you get this together, we have it confidence level. So in the calculator, I'm gonna write this down. 82 minus 4.97. So S bar minus error. So I'm just going to say 82 minus 4.97. You get 82 minus 4.97. I get 77.03. Less than then, if I make it plus, I get 86.97. So I got the two sides. Now, so I'm gonna put it here. For this, I got 77.03 less than mean, less than, okay. On the right side, I got, if you add these two, you get 86.97. Okay, so that is the confidence interval we are trying to get, and that is if the mean have to lie between this number and that number. So now, what does this mean? Interpretation. So we can say with 95% confidence that the mean reading scores of all fifth graders lies between 77.03 to 86.97. That's here, 86.97. So that's what this means. So when I say get the confidence, 95% confidence, that's what it means. This is how to interpret it. That the mean reading scores of all fifth graders lie between 77.03 and 86.97. So we are running out of time. So Zoom gave us only 40 minutes. So I'm gonna log out from here. Please log back in again at 8 o'clock so we can finish it, okay? Because it won't give us extra time. Okay.
With the same link.
Huh?
Use the same link.
Yeah, I'll put go to the same place and follow the link I put there, okay? Okay.
Okay.
Don't forget,
Okay.
please. Log back in at 8 o'clock so we can finish it.
All right.
Then I'll go. Okay.
All right.
Okay.
All right. I see you then. care.